Our next topic is Introduction to M function programming. Now we are going to start with M files. One of the most powerful features of MATLAB is the capability it provides users to program their own new functions. M files in MATLAB can be scripts that simply execute a series of MATLAB statements, or they can be functions that can accept arguments and can produce one or more outputs. M files are created using a text editor and are stored with the name of the form filename.m. The components of function M file are the function definition line, the h1 line, help text, the function body, comments. The function definition line has the form shown here. The h1 line is the first text line. It is a single comment line that follows the function definition line. There can be no blank lines or leading spaces between the h1 line and the function definition line. Help text is a text block that follows the h1 line without any blank lines in between the two. Help text is used to provide comments and on-screen help for the function. When a user types help space function name at the prompt, MATLAB displays all comment lines that appear between the function definition line and the first non-comment line. The help system ignores any function lines that appear after the help text block. The function body contains all the MATLAB code that performs computations and assigns values to the output arguments. All lines preceded by the % symbol that are not the h1 lines or help text are considered function comment lines and are not considered part of the help text block. It is permissible to append comments to the end of a line of code. M files can be created and edited using any text editor and saved with the extension .m in a specified directory, typically in the MATLAB search path. Another way to create or edit an M file is to use the edit function at the prompt. Next is operators. There are basically three operators, that is arithmetic, relational and logical. Now we are going to start with arithmetic operators. They perform numeric computations. MATLAB has two different types of arithmetic operations, that is matrix arithmetic operations that are defined by the rules of linear algebra, and array arithmetic operations that are carried out element by element and can be used with multidimensional arrays. The period or dot character distinguishes array operations from matrix operations. Next is relational operators. These are array operators, that is, they compare corresponding pairs of elements in arrays of equal dimensions. Both operands must have the same dimensions unless one operand is a scalar. In this case, MATLAB tests the scalar against every element of the other operand, yielding a logical array of the same size as the operand, with ones in locations where the specified relation is specified and zeros elsewhere. If both operands are scalars, the result is 1 if the specified relation is specified and 0 otherwise. Third are logical operators. They actually perform the functions of AND, OR and NOT. MATLAB treats a logical 1 or non-zero numeric quantities as true and a logical 0 or numeric 0 as false in all logical tests. Next topic is flow control. The ability to control the flow of operations based on set of predefined conditions is at the heart of all programming languages. MATLAB provides the 8 flow control statements that are summarized in this table. You just pause your video here and go through all these statements. Next is code optimization. MATLAB is a programming language designed specifically for array operations. Taking advantage of this fact whenever possible can result in significant increases in computation speed. So there are basically two important approaches for MATLAB code optimization, that is vectorizing loops and pre-allocating arrays. So first of all, we will discuss the vectorizing loops. Vectorization in MATLAB refers to techniques for eliminating loops altogether using a combination of matrix or vector operators, indexing techniques, and existing MATLAB or toolbox functions. Vectorizing simply means converting for and while loops to equivalent vector or matrix operations. It can result in increase in computation speed as well as helps to improve the code readability. Second is pre-allocating arrays. Pre-allocation refers to initializing arrays before entering a for loop that computes the elements of the array. To improve code execution time, the size of arrays can be pre-allocated. Pre-allocation is simply consists of creating arrays of zeros with proper dimension. Next is interactive input-output. To display information on the screen, disp function is used. Input function is basically used to input data into an M function. Function strread is used if the entries are a mixture of characters and numbers. To compare strings, strcmp function is used. The function can be modified to accept lowercase characters by converting any input to lowercase using lower function. Any input character string can be converted to uppercase using upper function. Next is cell arrays. Cell array is a multidimensional array whose elements are copies of other arrays. They provide a way to combine a mixed set of objects, for example numbers, characters, matrices, or other cell arrays under one variable name. To select the contents of cell arrays, an integer address is enclosed in curly braces. The most important property of cell arrays is that they contain copies of the arguments and not the pointers to the arguments. Our last topic in this lecture is structures. Structures are very similar to cell arrays in that they allow grouping of a collection of dissimilar data into a single variable. However, unlike cell arrays, in which cells are addressed by numbers, the elements of structures are addressed by user-defined names called fields. Fields adds clarity and readability to an M function. So this is all for this lecture. In next lecture, we will discuss about intensity transformation. Thanks.